Apple's AI Gambit, Silicon, SDK, and the distribution play. Apple dropped the M5 Pro and M5 Max MacBook Pros this week, and the spec sheet reads like a declaration of intent. The new chips use a fusion architecture that combines two dies into a single SoC, embedding a neural accelerator in every GPU core. The results: up to 4x faster LLM prompt processing versus M4 Pro/Max, up to 8x faster AI image generation compared to M1 models, and 128 GB of unified memory on the M5 Max with 614 GB/S bandwidth. SSD speeds hit 14.5 GB/S, roughly 2x the prior generation, and base storage jumps to 1 TB for M5 Pro, 2 TB for M5 Max. The 18-core CPU features 6 super cores. Apple claims are the world's fastest CPU cores, alongside 12 performance cores tuned for multi-threaded workloads. Apple's pitch is explicit. Run advanced LLMs on device, train custom models locally, do it all on battery for up to 24 hours. The hardware is only half the move. Apple simultaneously released the Foundation Models SDK for Python, an open-source package that provides Python bindings to the on-device foundation model powering Apple Intelligence on macOS 26. The SDK lets developers run batch inference, stream text generation, and use guided generation with structured output schemas, all hitting the system model locally with zero cloud calls. It requires macOS 26 and Xcode 26, which means it's tightly coupled to the new OS generation. But for the Python-heavy ML community, this is the first official on-ramp to Apple's on-device inference stack without writing Swift. The strategic narrative writes itself, and commentators aren't being subtle about it. While the rest of the industry burned through $1.4 trillion plus training frontier models, Apple partnered with Google to power Siri with Gemini, paying roughly $1 billion per year to integrate the best external model while investing its silicon budget into making on-device inference competitive. The argument: the AI era won't be decided by who builds the smartest model, but by who owns the device that model runs on. Apple flips a switch and reaches 2.5 billion devices. Competitors chase subscriptions at $20 $200/month. Apple runs inference on device. Faster, cheaper, private. Whether this bet pays off depends on whether on-device models can close the capability gap with cloud frontier models fast enough. But the distribution moat is real. The zero-day collapse, when hours become minutes. Sergey Jep, CISO of CISDIG, launched the zero-day clock this week, a live dashboard tracking the collapse of time to exploit TTE from CVE disclosure to confirmed exploitation in the wild. Built on 3,515 CVE exploit pairs from CCKEV, Volncheck KEV, and XDB, the trajectory is brutal. In 2018, the median TTE was 771 days. By 2021, 84 days. By 2023, 6 days. By 2024, 4 hours. In 2025, the majority of exploited vulnerabilities were weaponized before they were publicly disclosed. The 1 day and 1 hour marks are projected for 2026, with 1 minute projected for 2028. Organizations need an average of 20 days to test and deploy a patch, but AI can now reverse engineer a patch, identify the vulnerability, and generate a working exploit in minutes. The act of fixing a vulnerability now accelerates its exploitation. EP introduces verifier's law to explain the asymmetry. In offense, feedback is binary and instant did the exploit work, so AI learns at machine speed. In defense, feedback is ambiguous, slow, and expensive. The annual CVE count hit 48,000 in 2025, a 520% rise since 2016. And 67.2% of exploited CVEs in 2026 are 0 days, up from 16.1% in 2018. Monthly patch cycles aren't inadequate, they're irrelevant. A companion story from Tai Duong at Caliph puts a human face on the offensive side. A self-taught hacker from Can Tho, Vietnam, no degree, no bootcamp certificate, dropped out of university before 20. Found 6 vulnerabilities in Google's kernel TF and exploited 4, including a 20-year-old Linux kernel bug CVE2025-38617. The bug itself was simple, which is the terrifying part. It survived 2 decades because it takes a particular kind of mind to notice it. The exploit, however, was fine art. Tai Duong says it took him 4 days and an embarrassing number of tokens to understand how it worked. Caliph published a step-by-step exploitation guide. The story is both an inspiring talent narrative and a sobering reminder that the talent pool for offensive security is global, deep, and not always visible to the industry's traditional hiring pipelines. The prompted 2026 conference in San Francisco crystallized how fast the offensive-defensive timeline is compressing. Nicholas Carlini from Anthropic showed LLMs autonomously finding and exploiting zero-day vulnerabilities in production software. A heap buffer overflow in the Linux kernel hiding since 2003, the first critical CVE in Ghost CMS, declaring these current models are better vulnerability researchers than I am. Google's Heather Adkins stated a near-term goal: shipping relatively bug-free code within 2 years, backed by Big Sleep zero false positives on memory safety bugs and CodeMender 178 autonomous patches. Trail of Bits went from 15 to 200 bugs per week per engineer using AI agent fleets. Derek Chen reported AI-powered vulnerability discovery at 61 cents per finding, with 60-plus CVEs submitted and 3000+ pending review. Day 2 of Prompted added equally sharp data points. Rob Lee from SANS compressed a 3-day intrusion investigation into 14 minutes using Claude with a forensic skills clay.md file. A real-world AI-assisted AWS attack went from stolen credentials to full admin in 8 minutes. But the AI accent hallucinated GitHub repo, training set sample account IDs, a GPU cluster named Stephen G. Poo Monster, made it the noisiest attack we've ever seen. Researchers found 37 vulnerabilities across 15-plus AI IDE vendors, including a zero-click MCP autoload attack in Codex that spawns a reverse shell on Workspace Open. Snap presented 10 new warrants. Capability-based tokens that reduce successful AI agent attack surface from 90% to 0% by constraining agent permissions at execution time, even if prompt injected. Johan Rayberger coined promptware as the successor to malware. Multi-stage, persistent instruction sets operating above the OS layer via prompt injection. AI security arsenal. Autonomous Pentesting meets the Grand Unified Map. NeuroSploit v3 is an open-source AI-powered penetration testing platform that illustrates how far autonomous offensive tooling has come. It covers 100 vulnerability types across 10 categories, runs a 3-stream parallel architecture recon junior tester, tool runner with perscan isolated Kali Linux containers, and includes a multi-layered anti-hallucination pipeline. Negative controls send benign requests as baselines. 25+ per vulnerability proof of execution methods verify findings. A confidence score rate 0. 100, and a validation judge serves as final authority. The payload engine ships 526 payloads across 95 libraries, with WAF adaptive transformation covering 16 WAF signatures and 12 bypass techniques. Exploit chaining is automated. SSRF to internal access, Esquali to DB-specific payloads, LFI to config extraction. It's multi-provider Claude, GPT, Gemini, Llama, LM Studio, and includes an MCP server with 12 tools. The maturity here is notable. This isn't a proof-of-concept wrapper around an LLM. It's a full autonomous pentesting stack with cross-scan learning and adaptive strategy. On the theoretical side, Pete Herzog published what he calls the Grand Unified Security Theory GIST, a mapping of 240 interconnected security elements across 4 dimensions, derived from quantum information properties applied to Newtonian spacetime. The framework identifies 16 categories of measurable security reality, each containing 15 discrete elements across 3 operational phases before, during, after an interaction, organized into positive categories security controls, trust properties, and negative categories exploitation, privacy. Herzog's core claim: a typical security checklist covers 40 of these 240 elements, and even the most mature compliance framework touches around 80. The practical implication isn't that you need to master all 240. It's that you don't know which gaps are irrelevant without mapping the full territory first. Whether GIST survives contact with real-world practice remains to be seen, but the framing of security as incomplete map is a useful corrective to good enough compliance thinking. AI agents go local. The developer desktop gets an upgrade. Liquid AI released LFM2. 24BA2B alongside local cowork, an open-source desktop agent that runs entirely on device with no cloud dependency. Tested against 67 tools across 13 MCP servers on a MacBook Pro with 36 GB unified memory, LFM2 averaged sub 400 milliseconds tool selection while fitting in roughly 1.45 GB of memory. Single-step tool selection accuracy hit 80% across 100 prompts, which sounds modest until you consider the interaction model. The agent proposes a tool, the user confirms or corrects, and when the loop is fast enough, even imperfect accuracy becomes usable because correction costs are low. Multi-step chain completion was weaker at 26%, which Liquid acknowledges. LFM2 works best as a fast dispatcher in a guided loop, not an autonomous autopilot. The model has been trained on 17T tokens with pre-training still running, and LFM2. 5 release with post-training and reinforcement learning is expected. For privacy-sensitive and regulated workloads where no data can leave the device, this is a meaningful entry. Claude Cowork is getting the CO treatment. Linus Belunas published a detailed framework for treating Anthropic's Cowork not as a chatbot with folder access, but as a delegated operator. The key insight: stop writing step-by-step prompts and start describing outcomes. Cowork reads and writes files directly on your machine, spins up parallel workers for independent subtasks. and connects to 50 plus tools via MCP Slack, Google Drive, Notion, Jira, Snowflake, etc. The framework emphasizes context files, 3 markdown documents describing who you are, how you communicate, and how you want Claude to behave. That compound over time. Balloonaz reports a user finding a $14,000 month pricing anomaly in 45,000 rows of revenue data using the Data Analyst plugin. The limitations are honest. No session persistence, every new session starts fresh. Tasks die if you quit the app, and heavy multi-step tasks consume usage fast. Google Workspace now has a CLI called GAWs, not officially supported by Google, but living in the Google Workspace GitHub org. The clever design, GAWs doesn't ship a static list of commands. It reads Google's discovery service at runtime and builds its entire command surface dynamically, meaning it automatically picks up new Workspace API endpoints. It exposes 100+ agent skills via skill.md files, includes a built-in MCP server GAWs MECP, S-Drive Gmail Calendar, and supports model armor response sanitization to scan API responses for prompt injection before they reach your agent. Authentication is encrypted at REST AE S256, GC M with keys in the OS keyring. For AI agents that need to manage Workspace, this eliminates substantial boilerplate. Rounding out the developer tooling, Nitpicker runs multiple LLM reviewers concurrently on a Git repository, then aggregates their findings into a single prioritized report. Each reviewer is an agentic loop with tool access, read files, grep, glob, git commands, and a separate aggregator model deduplicates and synthesizes the reviews. The recommended configuration uses different providers to enforce diversity of thought. Claude for one reviewer, GPT for another, Gemini as aggregator. It's a Rust TLI, minimal and focused. Meanwhile, a father-son team documented their experience ramping up on Gastown, an agentic AI orchestrator. Their key discovery: don't issue CLI commands yourself. Ask the Mayor agent in conversational English and let it delegate to Polecat coding agents. The pattern mirrors a broader shift. The most effective way to use multi-agent systems is to stay at the intent level and let the orchestration layer handle execution. Agent memory and the architecture of faster inference. Dylan Andrew Canapiran published SAGE, Sovereign Agent Governed Experience, an open-source infrastructure layer for governed, verifiable, experience-weighted institutional memory across multi-agent systems. The motivation: existing agent memory systems, MEM0, MEMGPT, reflection all measure retrieval accuracy and latency, but never measure whether memory actually makes agents produce better outcomes. And they all do the same thing: store everything, retrieve what seems relevant. Memory without judgment. SAGE implements a governance pipeline. Agents propose observations. A 4-node BFT consensus network validates them using proof of experience reputation-weighted voting with domain relevance, accuracy, recency, and corroboration factors. And committed knowledge becomes institutional truth that can be challenged with evidence later. The stack runs entirely local. Comet BFT for consensus, PostgreSQL with pgvector for storage, Llama for embeddings, no cloud calls. Performance 956 REQ/S submissions, 21.6 MSP95 queries. The threat model is thorough. Memory poisoning, Sybil attacks, collusion detection via pairwise voting correlation, prompt injection via memory content rendered as data, never instructions. Whether organizations will deploy BFT consensus for agent knowledge remains an open question, but the framework identifies a real gap: memory governance for multi-agent systems. Open Trajectory GIM tackles a different gap: training agents to execute, not just converse. The framework treats entire agent traces: observation, tool call, outcome sequences as first-class training data using 3 complementary methods. Supervised fine-tuning on successful traces improves sidebench solve rates from 12.5% to roughly 20%. Online RL with live tool execution using a patch SkyRL fork pushes to about 29%. But the surprise result is GPA, genetic prompt evolution with Pareto optimization, which achieves about 35% solve rates using 35x fewer compute resources than RL, evolving prompts rather than updating weights. The caveat: GP only surfaces capability the model already has. The resource requirements are substantial: 1.40 GB plus VRAM for online RL, and the framework is at v0.10 with a single benchmark Sibench CTF. The broader question it raises is whether prompt engineering via gradient optimization will remain a useful distinction as agent post-training matures. On the inference side, a new ArcSiv paper introduces speculative decoding SSD, parallelizing even the sequential dependence between drafting and verification in standard speculative decoding. While verification runs on the target model, the draft model predicts likely verification outcomes and pre-computes speculations for each. If the actual outcome matches a cached prediction, the speculation returns immediately with 0 draft overhead. The optimized algorithm Saguaro uses geometric fan-out allocation, a novel cache-aware sampling scheme that trades acceptance rate for cache hit rate, and an adaptive backup strategy that switches speculators based on batch size. Results: up to 2x faster than optimized speculative decoding, up to 5x over autoregressive generation, while improving the throughput latency Pareto frontier. The key constraint: the draft model must run on separate hardware from the target, making this primarily a data center optimization. The Wave-Field LLM, a GitHub project proposing ON-log N language modeling via wave equation dynamics, offers a more speculative architectural departure, though details remain sparse. The Augmented Professional. DeepNote AI dropped as an open-source desktop application inspired by Google's Notebook LM. Built with Electron, React, and multi-provider AI Gemini, Claude, OpenAI, Grok. The feature list is ambitious for a beta. Upload documents and chat with sources via agentic RAG multi-query retrieval with subquery generation and sufficiency checking. Generate AI podcasts with multi-speaker TTS. Build image slide decks with a drag-and-drop editor. Create white papers, infographics, flashcards, quizzes, mind maps, dashboards, literature reviews, and competitive analyses. Complex content types use a research write. Review multi-agent pipeline with automatic revision if quality scores below 0.6. Cross-session memory persists user preferences per notebook. Local ONNX embeddings all ML6 v2 enable offline RAG with tiered fallback to Gemini API to hash-based embeddings. It even includes a deep brain integration for system-wide memory recall and file search. The known issues are typical beta: linear vector search, unbounded cache growth, API keys stored as plaintext. But as a demonstration of how much AI-native desktop tooling can pack into a single application, it's worth watching. The generalist-specialist debate is getting a rewrite from AI. Rick Deacon argues that agentic AI compresses the gap between vision and execution, turning generalists from synthesizers into builders with direct execution leverage. The pattern is familiar to anyone who's worked across offensive security, application security, product, and startup building. Breadth lets you connect dots, lead teams, and translate between engineers and executives, but historically you still needed specialists to execute. With LLMs and autonomous agents, generalists can prototype ideas, spin up frameworks, simulate security models, and iterate, all directly. The risk is overconfidence. Being able to prototype isn't the same as being able to ship production-quality work, and the multi-tool with every edge-sharp metaphor glosses over the domains where deep specialization still dominates. But the directional claim is sound. When tools lower the cost of specialization, the advantage shifts to those who understand the whole system. OCR provenance, a GitHub project for document provenance verification using OCR, aims to address the authenticity gap in an era of AI-generated documents, though the repository remains sparse on implementation details.